So this is an example of what? Bicyclo compound. Bicyclo compound. So in this bicyclo compound, here this carbon and this carbon, both the carbons are common for what now here? Both the rings. For both the rings, these two carbons are common, this one and this one. So they are bridge head carbons, I told you. Bridge head carbons. And now here, from this carbon, if we start number one, from any one bridge head, we have to start number one, I told you. From this, if we start. Now, these two are bridge heads. And now, how many bridges joining these two carbons? You check it here. So it is one path. It is one path with how many carbon atoms? Two carbon atoms. And this one, another path joining two head carbons with two carbon atoms. Don't take these two carbons. Ethyl carbons don't take. Here, these two carbon bridge. And here, joining 1 and 4, one more bridge is there like this. So it is one more carbon here. One more carbon. So like this, what here? One carbon bridge, two carbon bridge, and two carbon bridge. First, we have to follow which rule, which path here? Longest path we have to follow. So in the longest path with one ethyl branch is there here. So we have to go to this side only. So first carbon, then second carbon should be this one. Then third carbon, fourth. After this again another longer path, this one, 5, 6. Then lastly we have to use 7 to this. On seventh carbon iodine substituent is there. On second carbon ethyl substituent is there. So ethyl group on second, iodine on seventh. Carbon atoms there. That's what we say now here. 2 ethyl. 2 ethyl. Your first letter of ethyl is what? E. So 2 ethyl is there here. And 7 iodo. Why we wrote ethyl first? E. Here iodo I. So which comes first here? E. That's why here 2 ethyl, 7 iodo, bicyclo. Bicyclo 2.1. A 2-degree bridge, 2 carbon bridge, 2 carbon bridge, and 1 carbon bridge. So 2.2.1. Heptane. Total number of carbons forming the bicyclic ring is what now here? 7 carbons. Total number of carbon atoms. That's why hept. And single bond between all carbons in the ring. That's why hane. So heptane. So what is the name now? 2 ethyl, 7 iodo, bicyclo, 2.2.1 heptane is the IUPAC name of this compound here. So it is bicyclo compound. Bicyclo compound. Right now. So now here we also have tricyclic compounds. We also have what? Tricyclic compounds. We have discussed bicyclo, spiro, and now another one is what now here? Tricyclic. So tricyclic compounds. What are these called here? Tricyclic compounds. In this tricyclic compound, suppose if you draw like this, it will be only cyclo. Remember, it will be only cyclo. If you draw like this, it is bicyclo. It is bicyclo. What is this? Bicyclo compound, this one. But now if you take this one here, this bicyclo is this one is the bicyclo. Now here these two lines, suppose here this carbon, if they are joined. So here this carbon and this carbon, if they are joined with another line. This is called what now here? Tricyclo. What is here? Tricyclo compound. So these two carbon atoms are joined by one more line here. So it is what now? Fourth bridge. Fourth bridge. So if the fourth bridge is there between any two carbon atoms of the bicyclo compound, that is called what? Tricyclic compound or tricyclo we have to use. Tricyclo we have to use here in this case. So it is only cyclo. This one is what? Bicyclo. This one is tricyclo. So in this tricyclo now here again, we have to start number one from any one carbon like this here. So this carbon, these two are common, right? So these two are common for both the rings. So for both the rings, these two are common. Na? That's why these common atoms we have taken as what now? Head atoms. Bridge head. Now here first carbon we have taken, suppose here, first carbon. We can take here also. Now after starting from first, this between the two head carbons here, between the two bridge head carbons, how many paths are there? You check it here. Between this carbon. So this one is one path with two carbons. 2 carbon bridge, this one 2 carbon bridge, and this one carbon bridge. Between this carbon, 2 head carbons, 1 carbon bridge, 2 carbon bridge, again 2 carbon bridge. First we have to follow what? Longer path. Okay, longest path we have to select. So 2, 2, 1 bridge is there. And now here fourth bridge is, check it here, fourth bridge, this one. This fourth bridge is connecting what now? Second carbon and sixth carbon. Check it here. So numbering how we have given, suppose here first carbon we have given to one head carbon, then 2, 3, then another head carbon 4, then again longer bridge 5, 6, then 7 we have given here. Like bicyclo compound we have given numbering up to 7. After this, second carbon and sixth carbon are joined here. Second carbon, sixth carbon are joined by one fourth bridge. Another bridge called fourth bridge. So this fourth bridge is joining which atoms here? 2 and 6 atoms. That's why we have to take 0. Any carbon atoms there here in the fourth bridge? Fourth bridge with 0 carbons. Yeah, 0 carbon atoms. No carbon atoms in this. That's why what now fourth bridge is with 0 carbon. That's why we have to take 0 here. This 0 carbon bridge is connecting which carbon atoms of the bicyclic ring? 2 and 6 atoms. Atom 2 and atom 6. These two carbon atoms are joined by this fourth bridge. So 0 bridge here, 0 carbon bridge, the fourth one. That's why 0, 2, 6 we have taken. So we should not write comma here. We should write dots here. Dots. Okay. So 2 dot, 2 dot, 1 dot, 0. So like bicyclo, we have to give descending order. Remember, in bicyclo, we have taken what? Descending order. But in spiro compounds, ascending order we wrote, spiro compounds. But bicyclo compounds, descending order of this number of carbon atoms in bridge. Here also we have to write what? Descending order only. 2 dot, 2 dot, 1 dot, 0. The 0th bridge, that is fourth bridge, is connecting what? Second atom and sixth atom. That's why we write tricyclo 2 dot 2 dot 1 dot 0 to 6 heptane. So like this we have to understand what now here the concept of tricyclo compound. Tricyclo compounds. So it is what now here tricyclic ring it is. What is tricyclic compound? So tricyclo heptane it is. Totally how many carbon atoms are totally? 7 carbon atoms are there in this. That's why it is called what now here? Heptane. So tricyclo heptane. And numbers, the number of carbons in each bridge should be given what? In descending order. So now take this one here. What is the name of this compound? Here atoms, number of atoms here 1, 2, 3, 4, 5 atoms are here. So it is cyclopentane, that's one here. Cyclopentane. Is that clear? Suppose if you take one ring like this here, like cross. Now here, is it cyclo or bicyclo? This one? It is also cyclo. How many carbons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 there. 12 carbon. Dodecane. Cyclododecane like this. So number of carbon, it is only cyclic ring. Only cyclic it is. So cyclo compound, this one cyclo compound. This one is what? Bicyclo compound. This one tricyclo compound. Tricyclo compound. So in this way, we have to understand the concept of tricyclic compounds. Okay. So in tricyclic compound, how many bridges will be there now? 4 bridges. 4 bridges will be there. And here this fourth bridge will not be connecting the 2 head carbons. It is one head carbon. It is one head carbon. Bridge head, bridge head. The 2 bridge head carbons need not to be joined by fourth bridge. The fourth bridge will be joining any other carbon atoms in the bicyclic ring. So we have to mention the numbers of carbon atoms of that bridge, fourth bridge. So 0th bridge, that is fourth bridge, connecting 2 and 6. So this concept you have to understand here. Is the concept clear? Let's take the screenshot of this one. Yeah, next concept is that here. Now here in this case, now one cyclopropyl ring, this one, it is another cyclopropyl ring. When 2 rings of same type, when cyclopropyl, when 2 same hydrocarbon rings are joined, okay, with the single bond, sigma bond. It is sigma bond, not single bond means sigma bond here. When sigma bond joins that similar rings, in this case, number 1 is given here, number 2, number 3 in this ring. Here we have given 1 dash. What is this? 1 dash. It is 2 dash. It is 3 dash. So 1 dash, 2 dash, 3 dash we have given here. But here we have given 1, 2, 3. To one ring, we have to give 1, 2, 3. The other ring we have to give 1 dash, 2 dash, 3 dash. So why we have given 1 dash here? This carbon is directly linking to this carbon. Na? So directly linking carbon should be given 1, position 1. Here 1 dash. So 1, 2, 3. Here 1 dash, 2 dash, 3 dash. Now the sigma bond is connecting which carbon atoms? Here 1 of this ring, 1 dash of this ring. So here 1 comma 1 dash, 1 comma 1 dash, bicyclo propane, bicyclopropane. How many cyclopropanes here? 2. So 2 cyclopropanes. Bi means what? 2 here. Bi means what? 2. 2 cyclopropane rings are joined by sigma here. Sigma bond. So sigma bond is connecting what? 2 cyclopropane rings. Now connecting link is between which carbon atoms? First carbon and 1 dash carbon. 1 and 1 dash. That's why we say 1 comma 1 dash bicyclopropane we have to say. Now check the second example. In this case, it is what now? Cyclobutane. Each one is what now here? Cyclobutane. Each ring is what? By cyclobutane. So cyclobutane, cyclobutane, cyclobutane. How many cyclobutane rings? 3. That's why we have to use ter. Ter means what here? 3. So when 3 cyclobutane rings are joined by sigma bond. See, it is one sigma bond joining, it is one sigma bond joining. So when sigma bond joins what? The 2 or more than 2 rings, this type of nomenclature will be taken into consideration. Here, first ring is given what? 1, 2, 3, 4. Numbering is given 1, 2, 3, 4. Okay, so 1, 2, 3, 4 given. Next, in this ring now, here this connecting carbon should be given 1 dash, 1 dash, 2 dash. First we have to go horizontal path, numbering 1 dash, then 2 dash. Here also 1 and 2 horizontal path. So 1, 2, then we have to go 3, 4. Here 1 dash, 2 dash, then 3 dash, 4 dash. Again, this 2 dash carbon is connecting what with 1 double dash now here. Already dash we have used now here. We are using double dash. 1 double dash, 2 double dash, 3 double dash, 4 double dash. So while giving numbering here, 1 double dash and horizontal path 2 double dash we have to give here. So 1 double dash, 2 double dash, 3 double dash, 4 double dash. So like this now here, which carbon atoms are linked directly? We have to check here. This carbon, this carbon. So 1 comma 1 dash. 1 comma 1 dash.
20 minutes.
2 dash and 1 double dash. So 2 dash comma 1 double dash. Hyphen ter. Ter means how many times the same group hydrocarbon ring is repeated? 3 times. So ter cyclobutane. Ter cyclobutane. So 1 comma 1 dash, 2 dash comma 1 double dash, ter cyclobutane. So this way we have to understand what the concept of nomenclature of the compounds in which the similar hydrocarbon rings are joined by sigma bond. Is that clear, ma? Take the screenshot of this. Now check it here. So each ring is what? Tell me now. Each ring is what? Phenyl ring. Benzene with benzene ring means C6H5 here. Phenyl means what here? Phenyl group is nothing but C6H5 bond is called phenyl. So these phenyl groups are taken here. How many times they are repeated? 3 times. Now here sigma bond is joining. Here sigma bond is joining. Okay. Now first ring what we have given numbering: first carbon, second, third, fourth, fifth, sixth. Then 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. 6 dash here. After this, 4 dash is connected to 1 double dash. In the third ring, we have taken numbering 1 double dash, 2 double dash, 3 double dash, 4 double dash, 5 double dash, and 6 double dash. Okay, now connecting carbons, we have to check here. This carbon and this carbon means 1 comma 1 dash, 1 comma 1 dash. Then this 4 dash and 1 double dash, 4 dash and 1 double dash. Hyphen ter. Ter means how many times? 3 times. Ter means what? 3 times. So ter phenyl we have to say. Ter phenyl. Okay. So this concept is very important to understand here. Let's take the screenshot of this now. Now, once tell me this one here. If you take this one, suppose here I'm taking here cyclohexane ring. Again, cyclohexane ring. Not phenyl rings here. Cyclohexyl rings. Cyclohexane. Same thing. Again, numbering will be same. So what we take now? 1, comma, 1 dash, comma, 4 dash, comma, 1 double dash, cyclohexane. Cyclohexane we have to say. Instead of phenyl, we have to say cyclohexane. Yeah, because alternate double bonds not there here. So we say cyclohexane rings, all these things. Same concept. Okay. Okay. Now, next, another type of special nomenclature we discussed now, special secondary suffixes. So that concept, if you take now here, see here. In this now, in this chain, first carbon is started here. First carbon, second, third, fourth, fifth, sixth. Okay. So here CN group. How many times? 2 times. Is it CN or cyanomethyl? It is not cyano. So it is one cyanide group here. It is one cyanide group, but it is what? Methyl cyanide. Actually, here bond CH3 will be there. Bond CH3 means generally what? Methyl. In this methyl, one hydrogen is substituted by what? CN group. In the place of hydrogen atom of methyl, one CN group is substituted. Then it is called what now? Cyanomethyl. What is the name of this? Cyanomethyl. What is the name of this group now here? Cyanomethyl. It is not the cyanide group here. Now we cannot take that cyanide groups are repeated more than 2 times. Remember, 2 times only there now. This cyanide group at both the ends. This chain terminating cyanide, this chain terminating cyanide. 2 only are there here. This is not cyanide here. It is methyl cyanide. That means what? Cyanomethyl group. So we should not take what now? Special secondary suffix. Special secondary suffix we should not take, and we should give numbering from one cyanide to other cyanide. From one cyanide to other cyanide, longest chain numbering is taken. If you take like this 1, 2, 3, 4, 5, 5 only we are getting. If you take 1, 2, 3, 4, 5, 5 only we are getting. But if you take like this 1, 2, 3, 4, 5, 6, 6 we are getting. So 6 carbon atoms means what? Hex, root word. And between all the carbon atoms in the parent chain, single bonds there, na? Single bond means ane, hexane. And 1, 6 at first carbon nitrile is there, at 6th carbon nitrile is there. So 1, 6 dinitrile. This nitrile is what now here? Secondary suffix. What is nitrile here? Secondary suffix. So what is your name? And in hexane 1, 6 dinitrile. At third carbon, what is there here? Cyanomethyl group is attached. To the third carbon, what is attached here? Cyanomethyl. So we have to say now 3 cyanomethyl, hexane 1, 6 dinitrile we have to say. So it is the name of this compound. But we are not using carbonitrile, remember here. As 3 CN groups are seen here, we don't use here cyano means carbonitrile. Carbonitrile when we use, if directly cyanide groups are attached here. Suppose if we take this carbon here 1, 2, 3. This cyanide is there. Suppose here cyanide is there, here cyanide is there. In this case, 3 cyanide groups directly we have checked. Now numbering will be given 1, 2, 3 only. In this case, now carbonitrile we have to use. Secondary suffix name should be used what? Carbonitrile for this. This is called special secondary suffix name. Here numbering should not be given to any carbon of the cyanide groups. In this case, we have to say now more than 2 times cyanide groups are repeated here. In this case, but here now in this case 2 cyanide groups only there. 2 cyanide groups only there, not more than 2 times. When 2 times only cyanide groups are there, we should take nitrile only. We should not take carbonitrile. So this is taken as what? Methyl cyanide means cyanomethyl. That's all. It is not cyanide group here. So we have taken what now name? 3 cyanomethyl, which is what now? Substituent na? Complex substituent. Why it is complex substituent? If only CH3 is attached here, simple substituent. But it is CH2CN. cyanomethyl it is. So it is what complex substituent. So within bracket we have to write. So 3 cyanomethyl hexane 1,6 dinitrile is the name. Is that there? Take the screenshot if you need. Now, so next compound if you check here, see in this CHO group aldehyde, CHO group again aldehyde. Okay, so here in this case it is not CHO. Remember, it is not only CHO. It is what now here formyl methyl. Formyl methyl. Actually, bond CH3 means what? Bond CH3 indicates methyl, simple substance. In this methyl, one hydrogen atom is replaced by CHO. So it is CHO group is formyl group na, or aldehyde group here. So this formyl methyl we have to say formyl methyl. So here also formyl methyl. Okay. So the formyl methyl groups are attached to which carbon? Third carbon in the parent chain. Now numbering should be given to this CHO carbon and this CHO carbon. They have to be included in the numbering. So numbering 1, 2, 3, 4, 5, 6 carbon atoms. Okay. Now here first carbon and sixth carbon. Both the cases we have al all. All means what now? Secondary suffix. Al all means what? Secondary suffix name. So secondary suffix we have to use here. We should not use carbaldehyde here. We should not use carbaldehyde. Carbaldehyde is what? Special secondary suffix of CHO. That special secondary suffix of CHO, that is carbaldehyde. In which case we have to use if CHO group is repeated more than 2 times. But in this structure now, CHO groups only 2 times there. These are not CHO groups. We have to say formyl methyl, again formyl methyl. Therefore, we have to take what now here? Hex, 6 carbon atoms in the parent chain now, totally, including this carbon, CHO carbons, 6 carbons with all single bonds between. So hexane. And first carbon Al all, sixth carbon Al all. So 1,6 di all. Al all is what now here? Secondary suffix of CHO. Then in the parent chain on the third carbon, if you take numbering here, first carbon if you take here, 1, 2, 3, 4 substance we are getting here. Substance locants we are getting 4. But if you take numbering from right to left, we are getting third position. So it should not be taken here. Okay. So 3, 3. 2 times there na. Same formyl methyl, how many times there? 2 times there. So 3, 3. Bis here. Bis means what now? 2 times. Bis means what here? 2 times. So bis indicates what here? 2 times. 2 times complex substance is repeated here. Why we are not using by here? It is not simple substance. Okay. Why we are not using dimethyl, like dimethyl, why we are not using? It is also not used here. Di means it is for simple substance we take di. But here we are using what? Bis. Bis is used for what now here? Complex substance. So complex substance name should be written within bracket now. So we have to say what now here? Bis. So 3, 3 bis formyl methyl. 3, 3 bis formyl methyl we have used here. Okay, ma. So like this what you have 3, 3 bis formyl methyl hexane 1,6 diol is the IUPAC name of this compound here. Is that clear, ma? So it's about 3, 3 bis formyl methyl